Yeah, this will take about 10 minutes. I just want to show off some fun little projects that I've kept myself busy with over the past year or so. A little bit about me. I'm relatively new to Melbourne. I've been in electronics and in the industry for quite a long time, and I'm in the third phase now, really. And I've managed to, I'm quite proud of the fact that I have 5 children, but unfortunately I've only managed to produce one other geek. Actually, that's not fair, because others are geeky. One's a pilot. I'm quite proud of that. Anyway, what I wanted to show tonight was something I built. Started off by just measuring temperature, house temperature, and turning that into a colour, and then I extended that. And so terrible name, but what I wanted was to be able to get a quick indication, quick visual on the status of things. But having been a technician for a long time and knowing you don't need a lot of detail to know the status of something. That's basically the principle. So a couple of days ago, that was good. The outside temperature was comfortable. The South Marine train line was running properly, and I'll get into that later. The outside fridge freezer is working as it ought, and the office temperature was good as well.
Doesn't exist anymore, but it's running on time.
But of course, life isn't always like that, and for some reason the video isn't running. But like, here we go. So a couple of days ago, yeah, it was getting very hot outside. The train line was a bit funky. The fridge was good, and it's getting warm in the office. And that's a little ESP 8266 floating there. So the metro status. Yeah, we say that necessity is the mother of all invention. What happened is I dropped my partner off at the railway station, as I do every morning, drop her off, drive home. I get home, I get a phone call. Darling, did you know the trains weren't running? And I go, oh crap. I've got the Notify app on my phone, but I'm not a morning person. I don't like mucking around with my phone first thing in the morning. I forgot to check. Had I checked, I would have known that the trains weren't running. No point taking you to the station. And so that's kicked off. I need something better than a Notify app. I want something that when I get up in the morning with groggy, I just want to know with an LED whether the train line is fine or not. So I found out that the PTV Metro does have an API, but it was broken at the time of the build. So I reverse engineered the Notify app, and there's a heck of a lot of data that comes down on that Notify app, so I offloaded that to my server. And then I published extracted and published the critical bits of data to a private ThinkSpeak channel, and that's kind of what it looks like. It just publishes every I don't know, 30 seconds or so. It does a query on the PTV site and publishes whatever the status is to ThinkSpeak, and then my monitor downloads that number and interprets it, changes it to a colour on the LED. Now, the reason why I've got three lines, we use the South Marine, or it's now the Mernda line. Sometimes the Mernda line is down, but it doesn't mean that all lines are down. So if the Mernda line is down, chances are that the Greensboro or on the east, or the upfield on the west is okay. So either drop the partner off or pick her up from Greensboro or from Sydney Road. So what we saw with the flashing is when everything is good, I'm getting the status of the main line. When things are bad, it flashes, and it's a code. So I first get the status of this one, of the main line, then the next best one, which is Hurstbridge, and then upfield, and then it cycles through again. So I can see that there may be major delays there, but this one's fine. So that'll be flashing green. Then I just tell my partner to just jump on the Hurstbridge line. And that's what spawned Stanley. So Stanley here, I'm sure you can see Stanley, is, well, while I've got the status at home, it's good for my partner to know what's going on when she's in the office. She doesn't want the notify app on her phone. She'll much rather say, "Hey Pete, what's going on with the trainers?" So I have to tell her. And then I glance at my monitor and go, "No, everything's fine." Or, "Yes, there are delays." Go. And then it's my job to tell her which train to get on.
So tell us, what is it now?
It's going yellow. So get yellow, yellow, green. That's telling me that yellow is works. That there are works going on. There's the loop. The loop is closed at the moment for maintenance, but the upfield line is fine. So because I saw it was yellow, I go. They actually, to their credit, PTV do actually give quite good information. And the reason why I put Stanley into a toy was that I've actually done something similar before. I had the privilege a number of years ago of running the IT teams for Wellington and Wellington Public Transport in New Zealand. And at that time, I didn't know too much about web services, APIs, or JSON, or Python for that matter. I only knew how to spell Python. So no better way to learn this stuff is to actually do something. And so I replicated a platform display sign. It's actually running on a Raspberry Pi using big Python. And that's where I learnt Python. And my motivation here was to, a future iteration, I already had the ESP8266, was to get rid of the Raspberry Pi and build the whole thing into the bus. I might still do that at some stage, but it's far more practical to do something really useful for my partner, and she loves it, and her colleagues love it. So as I said, it's also got the outside temperature. The other LED is the CVD temperature, representation of the CVD temperature coming from OpenWeatherMap. And I'm collecting her office temperature of spliced in a one-wire DS18B20 into the cable. I did actually originally build the thermometer into here, but these 8266s generate quite a bit of heat. Yeah. A bit more about the LEDs. When Mother says something, so we were sitting in the office is adjacent to the living room, and the lights were really bright, of course, because it was night time. Aren't the lights a bit bright? She said one evening in a way that wasn't really a question, so everybody's got a partner knows exactly how those sorts of things are said. So that I ended up going on quite an interesting little journey into timekeeping within MicroPython. What's going on here? So rather than put a LDR into this extra component, I thought I'd just make use of information that's around and do something a bit sensible. So I've worked in councils for a long time. The street lights, the old style ones that are controlled en masse are actually based on twilight. There's a thing called civic twilight, which is half an hour, depending on sunrise, sunset, half an hour from sunrise to sunset. So I decided to use that. And so dim the thing at night from twilight, and after twilight dim it even further, and then off at bedtime. But I needed accurate timekeeping, the sunset times and daylight savings times, which is all a bit of fun. So the NTP time module, I modified that and added time zone, and I also worked out how to do the daylight savings. It's a bit different to how other people have done it, but when I did it that mid-year last year, I couldn't actually find a workable algorithm that I could just transplant. But this works. And OpenWeatherMap publish the sunrise and sunset times, and so with some simple maths, I can get this thing shutting or dimming the LEDs. And I had to do a bit of fault finding because my initial algorithms weren't that good. I made a few assumptions, and during the day I found that the LEDs were dimming when they shouldn't be. So I rewrote that part of the code and ported it, and that's what it looks like. So daytime, twilight, nighttime, twilight, and so I've got no miss switching. It's all working the way it ought. And through that process, I wanted to create a 12-hour timer. I found that I couldn't, and that's when I discovered that the maximum period for machine time is this number here. I don't know if anybody knows that. I'm looking at you, Damien. It's a really weird number, and I actually found this number and tested it after I found it, but it's actually published in the Lure doc for the ESP.
Did you write this in the forum?
Yeah, I reckon.
I've been meaning to raise a ticket on that, yeah.
Oh, thanks, yeah.
Oh, we'll get to
I,
that, yeah.
quite frankly, I didn't know what to do, so
No.
I thought I'd worked out that Maddie White was you.
Yeah.
Yeah. So it'd be really great if that was in the document. Somebody else had actually raised it, asked the question about a year ago.
Yeah. And we'll get it fixed.
Yeah. So I don't know if there's a fix.
Well, just document it. It's
You
fine.
did just document it, but
Yeah.
if somebody wants to work out why it's that number, it's a really weird number. Oh, and a few other things. On my my status monitor, I was monitoring the outside fridge freezer. The reason why I was that the freezer kept icing up, and I'm not a refrigeration engineer, and nor did I want to be. I can consider myself one now. I know far too much about them. But did you know, hands up, anyone who knew that they actually stick heaters inside freezers? And that is the heater glowing after I figured out that there was a heater and its sole purpose is to de-ice the heat exchanger.
No, that makes sense.
Yeah. And I only discovered that by, because what I was doing was manually defrosting. I emptied the freezer, put a fan heater in there, defrost it, and then about a month later it was iced up again, and then I put some thermometers in there, and I saw a bit of a pattern forming, and then I put an algorithm around that to use the LEDs to tell me hey, it's time to defrost the freezer again, and then I was studying. This was going on for a few too many months, and I studied the circuit diagram of the freezer, and I saw this thing that looked like a heater, and to me, it's an engineered solution. There's a problem that you solve it. You can stick a heater in a freezer. It works. And I don't have the graph, but yeah, the heater gets up to about plus 17 degrees. But that, as you can see, is red hot. My other project is a power meter. The whole idea around this is to indicate relative power consumption inside the house. So we've all got a power company power meter, but that's not really useful for a consumer. The whole idea around this is that I clip these, I think some of you guys are probably familiar with them, onto different circuits inside the house, behind the switchboard. So say for the power points for the lighting circuit, for your stove. And so I've got different size current transformers here. It's my diagram up here. So I've got the current transformer going through a precision rectifier. So that's a couple of op amps and diodes into a analog digital converter, and then our ESP8266 doing its thing. This is kind of the instantaneous reading every 5 seconds, and then I've created a running average that smooths it all out using an hour's worth of data, and I haven't finished it, but that should relate to the kilowatt hour consumption. It should match. Should. and then
How do you calibrate that? Like you're saying it should match, but like,
quite
how
frankly,
confident are you that?
oh, I'm not confident at all. I trust that the power companies are doing the right thing, and it'd be pretty hard to contest. I think I don't have the high quality test gear that a calibration setup would have. So literally used a power meter and a multimeter to get a rough reading, and it was good enough. I used a known load and then calibrated it.
It's tricky these days because a lot of our modern devices don't have a sinusoidal current consumption, like they're just conducting on the peaks of the wave, so it makes it tricky.
Yeah, good point, David. What I'm not doing is power factor. So that's where we measure the phase of the current versus the voltage. I could, but that's another thing that I might do, but I'm not sure about the capability. Is there are plenty of Arduino projects around there that do just that. They have the AC going straight into from the current transformer going straight into analog digital converters on the Arduino. To me, for what I want is an overkill, but that way that they can actually measure the phase difference. Yeah. From that you could work out power factor. But as I said, I'm not interested in that. Other things I'm doing is over this Christmas I made an audio VU meter with a Raspberry Pi, with ultimately trying to get it to get ESP8266 to do the same. So it's proof of concept on the Raspberry Pi. That worked. I was happy with that, and I was even happier still with the spectrum analyzer. Fast Fourier transform, even though I've got a background in analog electronics and I know what harmonics do, fast Fourier transforms was something that I never lifted the lid on. It's a bit too scary, and yeah, I wasn't wrong. So I got it working on the Raspberry Pi. That's really interesting. There isn't a MicroPython, as far as I know, module for fast Fourier. There is one for Arduino, but that's something that I want to look at doing. That's for those who don't know. You take a analog complex analog signal. Complex analog signal is made up of fundamental plus lots of harmonics, and it's about measuring the power of the amount of energy in the harmonics, and that can then be used to give added up can give you power in power bands. So I'm initially going to do it with hardware, and that's it. Is that about 10 minutes? Thank you, John.
That's really cool. Thank you.
Oh, any questions? Any other questions? I really love what you guys are doing, by the way. See, I occasionally have a look at what you're doing on your YouTube channel and things. And Damien and Matt, it's, yeah. As I say, I've only been here for a couple of years, and this is my second meeting. But yeah, this is something that really resonates. Thanks.
Thanks for the talk.